So let me just tell you the ENI use cases. So there is a first use case of the ENI. What we can able to do with the ENI? See, we have a web server, right? So we have a Ethernet 0x0 interface and Ethernet 1x1 interface. Let's suppose this Ethernet 0x0 interface has a public and private IP address both, and this EC2 this web server, like users from internet can able to access this web server through the internet gateway using this elastic IP address. Let's suppose we do have a IPsec tunnel between AWS and your on-prem environment. And let's suppose in on-prem environment, there is a user, this user, and he wants to do some type of configuration with this web server, because from internet we are only allowing the traffic on TCP port 80 and 443. We are not allowing any type of traffic on SHS, because if we want to manage, if we want to upgrade something, if we want to do some changes on this web server, we have to take the SHS access, right? So what we will do in that case, we will allocate one more ENI. That ENI we will put into the private subnet, and now this ENI we will use as a management traffic, and we can able to log in from here into this particular ENI, this particular IP address. So that's how we can able to utilize the ENI, or this is a case of dual home network. Okay. And guys, high availability solution by attaching ENI to hot standby instance in case of failure means sometime what happen, let's suppose we have a EC2 instance, right? And there is a one ENI which is attached with this EC2 instance. And this is the primary IP address and this is the elastic IP address of this particular ENI, right? Let's suppose this host failed due to any reason. So what we can do, we can able to detach the ENI from here and we can attach it with this particular VM. Now this VM will act like this particular VM. So we can also able to go with the hot standby switchover or failover when one of the EC2 instances failed. There is a one more use case, like we can able to create the management network. This I have already covered. So these are the two use cases available with regards to your elastic load balancers, elastic network interface, guys. 1 minute, let me just close it. Go here. So we have a creating management network or creating a dual home instance, means one instance can have two interfaces or it has two IP address. Mahesh, it is in the same subnet only. Okay, it is a part of same subnet. Okay, we can create and configure network interface and attach them to instance in the same availability zone, means because ENI has a scope at the availability zone level. If you have a two subnets into the same availability zone, and if you have a two machines into these subnets, then we can able to, basically attach and detach these EMI, because it has a availability level scope. Okay, now your account might also have a requester managed network interface, which are created and managed by AWS service to enable you to use the other resources and services. This is something different. We will discuss that part as well when we will discuss your endpoints and gateway load balancer. You can manage these network interfaces by yourself, right? This is the document which you have to go through with that. Network cards, as I have discussed, like ENI represent the network card and all, right? So you can go through with that. And one more thing, see, as you have seen, there's a one question as well, like why so there's a one question like why I'm only able to attach two ENI with the T2 micro, right? So for that type of silly question, you can reach out to AWS and they will answer you properly. Okay, this is the restriction which they have put, because that particular device is not capable of handling that much data. Okay, it's a hardware level dependency. Like if you are using C for X large instances, you can attach around 4 ENIs. with each supporting around 15 IPv4 private IP address and 15 IPv6 IP address, right? So you can use the high-end boxes which have a high CPU, high RAM, and high SSD, like high networks, high CPUs, high RAM, right? High memory with regards to SSD. In that kind of cases, you can attach multiple ENIs for handling the traffic and all. Okay. Now, so this is what which I wanted to cover with regards to your ENIs. We have discussed the BPC router. Now, guys, remember one thing. If I'll go here, now whatever VMs I have done, let me just terminate them. I will terminate all the VMs here. Let's wait here. They are terminating. Go into your ENIs. This is the one which I have created. So go here and delete it. Go into your elastic IPs. And guys, always remember, if you are basically using any elastic IP, just delete them. If you are not using them, release the elastic IPs they have released, because if you will not release, then it will basically charge the amount. No. See, ENI we cannot able to, ENI has just a scope with within the AZ. Okay, we cannot able to use them between different accounts. There is a one more concept which is endpoint service and all. Okay, and these things we are going to discuss, that time I will cover. They don't have a cross region scope. Okay, now all my EC2 instance is terminated, all ENI is gone, all elastic IP also gone. Now, okay, cool. Now let me do one thing. Let me just refresh here. Now I will do one more practical, but before doing any of the practical, go into my security groups first. Let me delete these security groups. I delete this allow all. Okay, now let's try to understand the firewalling concept in your AWS. Now, if I'll go here, so in your BPC, in the AWS environment, in your in your BPC, basically we have a two type of firewall things. If we want to allow the traffic or we want to deny the traffic, right? These type of things we can able to achieve with the help of security groups and the network ACLs. Means, if see, we have in my BPC, like I have a subnet 1, subnet 01, subnet 02. I have a web servers on my subnet 1. I have a app server and database server on subnet 2, right? Now, if I want to allow the traffic, or I want to deny the traffic, what? Either I can able to control on the basis of security group, or either I can able to control on the basis of network ACL. So these are the two type of firewalls we are having in your AWS BPC. But before explaining that concept of firewall, guys, tell me one thing. What is a stateful firewall and what is stateless firewall? What do you mean by the stateless and what do you mean by the stateful? Anyone have any idea about the stateful firewall and stateless firewall? Or anyone have idea about this? What is stateful inspection? I have a PC1 here, 10.0.0.1, 10.10.1. Let's suppose it is running the service on TCP port 80, means it's a web server. Okay, now guys, router is a stateless firewall or stateful firewall? Or tell me one thing, if I want to allow something, if I want to deny something in this router, how I can able to do that? We have to use the access control list. That's correct. Now, see, guys, state stateless firewall are the access control list in your routers. Means, what is the exact meaning of stateless? See, if we want to allow something, let's suppose I have created one ACL access less than on this router, and I have allowed if traffic coming from PC1 going towards server, and the destination port is 80, just allow it. So what it will do? Now this PC will send the request to this router, and now this ACL10 I have to apply it in the inbound direction of F0x0 interface. Right? That's how the access list works. Now, when this router receives this traffic, what he will do? He will basically forward the request till the server. Now, when this server will reply, so what it will do? This router now block this reply, because if you want to allow the reply as well, you have to basically create one more ACL, which is ACL20, and you have to write traffic coming from server towards the PC1. If the source port is 80, sorry, so destination port is 80, because he will basically, sorry, source port is 80, allow it. Means we have to open a rule here. It is not maintaining any type of connection table or session table, right? So what used to happen generally, these routers, they will not maintain any type of connection table or the session table. Okay, and if we want to allow the traffic from in to out or out to in, what we have to implicitly write these particular access control list, then only they will allow the traffic, right? But like we have a firewalls nowadays. If I'll take example of firewall, if I'll take example of like Palo Alto firewall or Cisco ASA firewall, these are the stateful devices, means they will maintain the state of a connection. Means, let's suppose if this PC wants to do the communication with this server, so what this PC will send the first packet. What is the first packet here, guys? It's a TCP send. TCP send received by the firewall. Firewall will start doing the processing, and he will forward this packet towards the server. Now server will reply with the TCP SYN plus ACK. Right now, when he will reply this TCP SYN plus ACK, what it will do? Now this fire will check the state table or the connection table. So what used to happen when this firewall received this first TCP SYN packet, what it will do? This TCP SYN packet have a source IP address, which is 10.0.0.1, destination IP address, which is 10.10.10.1. Source port, it will basically choose any random port, or it will basically choose the any port starting from 1024 till 65535. Between this range, let's say it has picked up 3050. And guys, this particular port is known as a ephemeral port. Just remember, this is a AWS terminology, or I used to call it like a, we have a well-known port numbers, and after whatever range is available, we can basically utilize that range for that. Then we have a destination port, which is 80. What is the layer 3 protocol number for TCP connections, guys? What is the layer 3 protocol number for TCP? It's 6, right? So what used to happen, see, if it's a Cisco ASA firewall, it will basically take this 5 tuple information. It will take this 5 tuple information, and it will basically store that information into the session table, into the connection table. In ASA, it is called a connection table. Okay. Now, when this server send the reply will receive by the firewall. So what it will do, this firewall will not will what it will just check the connection table, because it has a entry when he has received the TCP SYN request. That time he has created this entry. So what it will do, he will basically allow this particular traffic. It will bypass the couple of checks. What it will do, it will bypass couple of checks. Okay. So that is the stateful nature. And guys, this technology is developed in 1993. There's a person called Nirjuk, and he was a part of Checkpoint Tech team that time. And today, this the same person. He is the founder of Palo Alto Networks, because this is the person only who have basically invented this Palo Alto firewall, and he is a CEO of Palo Alto. And one more thing, guys, let me see this stateful thing. I used to explain very in depth on my Palo Alto batches. So you have to just remember, in a stateful inspection, my device used to maintain the state of the connection. And whenever it will receive a subsequent reply and request packet for that particular flow, what it will do, it will bypass the ACL checks and all. Okay. Just give me 1 second. I have, I think, one video on my YouTube channel for the same. Stateful inspection, guys. Okay, I'll go here. Stateful. Okay, this is the, I think on this demo, I have here also I have covered stateful inspection. This is in Hindi. Okay, so guys, what you have to do, these are the two videos on my YouTube channel. Just visit them. You will get the very good idea on the stateful inspection. What is that, how it works, everything. Okay, because I have discussed in very in depth. Yeah, I got answer like 6 tuple in case of Palo Alto. Palo Alto included the source zone as well. Okay, in case of ASA, only there are 5 tuples. Okay, now guys, let's try to understand the firewall thing. So as I mentioned, in VPC, we can only will to allow or control the traffic on the basis of security group. Now, if you have observed in this diagram, this security group generally we used to apply it at the VM level. Your security group is applied at the VM level. Means in your virtual machine, whatever ENI we are having, your security group is applied into these ENIs. So means if you want to restrict the communication at VM level, we will use security groups. And your network ACLs, they will basically apply at the subnet level. Means if we want to allow or deny the traffic between two subnets like subnet 01 and subnet 02, we have to go with the network ACLs. Now, your security group is a stateful firewall, means they will maintain the state of the connection. But your network ACL is a stateless firewall, means we have to allow the explicit inbound and outbound traffic. Just remember. So, guys, now I think you got the idea here, right? See, when we will basically we have security groups works at the VM level, and your network ACL works at the subnet level. Are you comfortable with this statement, guys? If I'll go here on my VPC console, you can able to see we have a security, we have a network ACLs, and we have a security groups, right? These are the two things we are having. And by default, when you will create a VPC, you will be able to see one default security group. So you can always put a name VPC01 default SG security group. And also, guys, when any default security group is created, if you will check, it has a inbound rules and it has a outbound rules. An inbound rule, it is allowing all the traffic. In outbound rules also, it is allowing all the traffic. We have a network ACLs. So this is the when you will create a BPC, it will create one default network ACLs as well. BPC 01 default NACL. And now this NACL has a attachment with all the subnet, because we have this particular NACL attached at the subnet level. And by default, it is also, it has a two rules, an inbound and outbound. Has a two type of rules. And inbound, it is have a number 10, number 100, which is allowing. So it will allow all the traffic by default. And second one also, it will allow all the traffic by default. Now, let's do these particular practicals now. Okay. Okay. So guys, firewall inside this BPC. So we have a two type of things inside the BPC for firewall perspective. The first thing is your security group, and second thing is network ACL. In production environment, people use security groups, guys. Network ACL is not used by the people a lot. Okay, always people go with the security group because network ACL become bit complex. Okay, because and also they are like having the stateless nature. Okay, so security group. A security groups controls the inbound and outbound traffic from the instance. Guys, I hope you know what is inbound and outbound. What is inbound traffic? Let's take an example. Let's suppose I have this particular VM. We have a one router here. We have a one router here. And I have one PC here. And we have a one PC here. This is PC 10. And this is PC, let's suppose 01. Now this PC wants to send some traffic towards this PC 10. Or let's just go like that. I'll just have this setup. I have a VM0 and I have a PC2 and we have a router. Now, on this VM, what I have done, this PC10 has, let's say, have IP address which is 10.10.10.10, 10.10.100. So on this VM, let's suppose I have just opened the ping and I have done 10.10.10.100. Now, which type of traffic it is? Means this traffic is going out from your VM, right? So it is known as outbound traffic. And now when this, let's suppose this PC, this let's say IP address of this VM is 172.16. 1.1, and now this PC will send a ping request towards this VM, means the traffic which is coming towards your VM is known as a inbound traffic, means coming inside your virtual machine, and the traffic which is going out from your virtual machine is known as a outbound traffic, and your security groups can able to control inbound and outbound traffic. For instance, just remember, a security group, a security group act as a virtual firewall for your ENIs, means your security group generally, see, it is not true. We will allocate at the VM level, but in actual it is applied on the instance, and it will apply, generally we will apply at the instance level or VM level, but in actual in a backend it will apply at the ENIs in your elastic network interface, okay, to control inbound and outbound traffic. Security groups act at the ENI level, not the subnet level. Okay. And security group attached to ENIs, not instances. Security group attached with the primary ENI. So whenever we will attach any of the security group with one of the VM0, and it has a two ENIs, ENI1 and we have a ENI2. Let's suppose this is the primary ENI, and we have attached the security group into this particular VM, right? That time your security group will attached here with this particular primary, and I just remember. Okay. Security groups are the fundamental of network security in AWS. They control how traffic is allowed into or out of your EC2 machines. When you create a BPC, it comes with a default security group. You can create additional security group for a BPC, each with their own inbound and outbound rules. You can specify the source IP, source port range, source IP or source IP range, port or port range, protocol for each inbound rules. You can specify the destination, port range or protocol for each outbound rule. Okay. Security group is not having explicit or custom deny rule, guys. Just remember one thing, whenever we will use the security group is always come with the allow statements. You cannot able to configure any type of deny statement, just remember, and it is not having any type of explicit or custom deny rule at the bottom, or there is no deny rule. All rules having only allow statements. Okay. You can assign a security group only to resources created in the same BPC as the security group, or you can assign multiple security group to a resource, means we can able to assign one security group or multiple security group into the same machine. Security groups are stateful. You can reference another security group as a source as well, means inside one security group we can reference other security group as well, and we will do all these practicals so you will understood the things properly. Let's first try to understand the theoretical aspect. Now, now guys, let's do the practical, and after that I'll just come back. Now, I'll go here. This is the right now you can see I just have a default security group, right? So what I will do, guys, tell me one thing. Let's take an example here. I will basically create this type of setup, or I will create this setup later. Let me first create one more setup here. Guys, I am audible properly. Just confirm by typing yes in the chat. So Oscar, you can able to check the primary ENI and secondary ENI by going into this ENI tab. Okay, I'll show you again. Let me just complete this security group. Now, guys, see, let's suppose I have this VM. VM0, it's just a Linux VM. Okay, now, so guys, there is a lag on my voice. Because one student has reported there is a lag. See, Bharat, I think you have a issue with your internet because I have a very good internet, even though back with the backup as well. So I will not have these issues. Okay, cool. Now, see, we have a, let's suppose, Linux machine here. So this Linux machine generally have a one elastic interface. So let me just denote this elastic interface like this. ENI, right? Now your security group will apply here. Security group 01. Okay. And after that, this particular Linux machine has a connectivity with your AWS router. Then this AWS router has a further connectivity with your internet gateway. And this internet gateway will have a further connectivity with the internet. I've just put ISP. Let's suppose there is a one user. Now, let's suppose on this Linux machine, I'm running the services on TCP port 22. I'm running the services on HTTP, which is port 80. I'm running the services, one more HTTP server I'm running on port 8080. And let's suppose I'm also running one service called FTP, which is running on port 21. So these are the services which I'm running on one of my Linux machine. Okay. Now, let me just deploy this type of Linux machine. First here, I'll go into EC2 console. Let me refresh it. I'll go here. Let me first create one of the security group. Okay. And I will just give the name security group 01. And this security group for BPC01. And guys, security group has a scope at BPC level. Just remember. Now, I want to allow SHS. Or let me go with I want to allow TCP traffic on 22, on port 80, on 8080, and let's suppose on port 21, which is FTP. This is my BPC. Here we can able to allow inbound rule and outbound rule, but let me just create this security group. I have created this security group and it is not having any type of rules. See, it just allowing in inbound, we don't have anything. For outbound, what? It just have one rule, which is allowing all the traffic. Now, let's go here. Let's create one EC2 machine. And I'm creating here VM01 SG security group. I will put SG. So which means I'm creating this for security group demo or security group labs. I'll go with this. I'll select my AWS 4 key pair, add it. And I will just put, let's suppose on my public subnet 01. I want public IP address and I use the existing security group, which is SG01 BPC. And on this particular interface, I want IP which is 172.16.1.100. And all these settings, I'll go and I'll just click on launch this machine. Guys, do one thing. Can you guys just log in, open Google and just type, what is my IP address? Go into this website and share your public IP address. You will be able to see your public IP address here. Just share your public IP address with me. Share 2-3 persons this public IP address with me. And also make sure you are ready with the putty. So I have received from Asutosh. Let me just put this is Hemu public IP address. Now let me just, for Asutosh guys, I need only 3, 4. I'm getting lots of. So let me just copy and paste here. This is from Ashu. What happened there? One minute. This is the one. Now another one from Ketan. Now there is a one from Sunil. There is a one from Suraj. I think these 4 are enough, guys. Okay, I can. There is a. Let me just use one more from Binay as well. I think I'm not able to copy and paste them. Sorry. Okay. So let me first write my IP address. Copy and go into Notepad and paste. This is for Hemu. So for Binay, which is 49.205.149.146. From Suraj, it's 103.38.68.221. And for Malay, which is 103.215.225.199. Let me take one more from Ketan, which is 94.128.27.206. This is from Ketan. Okay, these are the 5 public IP address I have picked, right? So what I will do in first go, I just allow the traffic from these particular public IPs. Okay, and we will see all these things. Now I'll go here. So my EC2 machine is up and running. This is the public IP address. Let me just refresh it completely because I have terminated the VMs, but I'm not sure why they have not removed yet. I'll just select this. This is the public IP address. And guys, on my security group, at outbound, it is allowing all the traffic. At inbound, it is not allowing anything. So tell me one thing, guys. Do I able to ping this particular VM? See, ping is not happening. Now let's first allow this particular ping with this particular VM. I'll go here. I'll add it. I'll add it one rule. And let's suppose I just want to allow all ICMP traffic. Let me just allow with anywhere means I'm allowing for everyone. Click on save. See, as soon as I have allowed the ICMP, I can able to ping. Guys, try to ping this IP address 44.204.208 and 36. Just try to ping this IP address. Are you guys able to ping or not? IP address is this 44.204.208.36. Just try to ping that IP and confirm. Are you guys able to ping or not? I have put that IP on the chat. I think Ketan able to ping, which means ping is working, right? No. Now let me just do the control C. Now let me just do one thing. I'll go here again. Let me edit my rules. Let me allow the traffic on TCP port 22. Means I just allow the traffic, which is here from here you can able to select. All these are the custom ports available, but you can also select like on the basis of custom, you can put port 22, but SHS is there, so you can directly select SHS. And let's suppose I want to allow from anywhere. Now if I'll go here, this is my security group. These are my inbound rules. Not this fault, this is the one, right? These are my two inbound rules here. Now this time if I'll open my putty, if I load my EC2 at the rate IP address of my VM, let me select the proper key here because I know key is selected, which is the wrong one. Day 4 key pair, I'll go and I'll just open it. Accept this particular request. Now, as I have accepted the request, you can see I can able to do the SHS. Why I am able to do the SHS? Because I have allowed the SHS traffic, right? Sudo -i passwd ec2-user admin at 123 admin at 123. Now what I will do, I in the same machine I'll run this command yum update -y. Let me update the packages. And even though if I have to, I will test the connect with the Google as well. Ping to google.com ping is working. Now I will do one thing. I will just type yum install httpd and nginx -y. I will install these two packages. Right. And let me install one more package, which is vsftpd. I will install this FTP service here. Now I'll go here. I will run this command nano /etc/conf/stp.conf file. And in this file, see, I have installed two web servers. So one is running in port 80. So I will run the another one on different port, which is port 8080. So here I have to just change the port number. And instead of 80, I will put 8080. Control X, Control Y, hit enter. Now you can type this command, which is service, or not. If you don't want to type service, you can type a system ctl enable httpd system ctl enable system ctl restart httpd. Now system ctl enable nginx nginx. Now system ctl restart nginx. Right. System ctl restart vsftpd. Right. Netstat -n. You can say I have all these settings here. Now guys, now do one thing. Let me run one command here. Tail -f/var/log slash stdpd access.log. Now, see, if I will go here, if I will copy this particular public IP of this VM, if I'll go here and if I will type and I will type port numbers, see, I am not able to access it. Guys, are you able to access this particular VM on this IP address? Just type try in your system. Are you able to access or not? Try on port 80, try on port 8080. It is not working, right? Why it is not working? Because we have security group, even though we cannot able to see anything here on the access logs as well, right? I have enabled the logging here. Now, what we have to do, I'll go into this security group. I will add in my inbound rule. Inbound rule means because right now I'm just dealing with the incoming traffic. Okay. The traffic which is coming inside my VM. So I'll go here. Let me just allow the traffic on port 8080. Let me just go with anywhere. Or you can also go with, let me just go with my IP. I'll add one more port here, which is TCP 80. Let me just only allow my IP address for a moment. I'll go here. Let me select TCP for 21. Let me just allow for only my IP address. This is my public IP address, right? You can see this is my public IP address. I have just allowed only my public IP. I'll go here. See if this time if I'll go here, see I am getting the web page. It's worked. Here also you will able to see the Nginx page. I'm getting the Nginx page, and even though you can be able to check the logs here. We are getting the access log. We have got the request from this IP address, right? So now you got the idea here how we have to basically create or how we have to allow the traffic. Now, see, right now if you guys able to access it, you will not able to do that. But if I'll go into this security group, if I'll go edit my inbound rules, and instead of this particular custom, if I will allow for anywhere, 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 and SHS also, let me go with anywhere. I'm allowing that traffic for everybody. Now guys, try to do the ping or try to do the SHS on port 80, and now you can see I am getting lots of requests from multiple peoples. So this is how we can able to control the things. See, I've got a request from this IP address, from this IP address, from this IP address, right? I'm getting these requests from multiple peoples for multiple IPs. So this is how we can able to control the traffic on the basis of security groups, guys. On the basis of security group. Okay, now see if I will refresh here, I will get the log here. And when you will access on port 8080, then only you can able to see the logs because I'm just checking the logs of my HTTP daemon. There's a one more Nginx logs I'm not checking. There is a one file for Nginx as well. cd slash war type ls. I think I forget the place cd.www, then ll. I forget the Nginx location. cd slash usr ll. Share. We have a Nginx somewhere here actually. Yeah, this is the Nginx cd Nginx ll. Okay, we just have HTML cd.html ll. Then we have this particular log file which is index.html. I think log file is not here. That file is created somewhere else. Okay. I forget the location exactly, not remember. Maybe on temp, let me just check. Otherwise, I can also able to show you that in temp also we don't have any, not an issue. We have just verified for one of the server, which is well and good. Now, see, on the same machine, I'm also running the FTP server service, right? Are you guys able to connect with the FTP as well? You can type FTP and the public IP address, which is 44.204.208.36. Username, you can type no type username, which is FTP, and password is also FTP. dir ll, okay, invalid command, quit, quit, or control D, I think. It's not working. Exit, not working. Quit, yeah, quit will work. So I think FTP anonymous login is enabled as by anonymous. No password, I hope. Oh, it is failing. Not an issue, but see, ultimately FTP is running, right? I don't want to like teach you here Linux. Otherwise, we can able to enable the things as well. Okay. Now, guys, see, on my VM, I am running this services like which is 22 on port 22 on 80, 80, 80, and 21, right? And we can able to restrict that access of these services using the security groups, right? Now, in my security group, you have observed here. Let me go into my security group. Let me edit that security group. Now, if you will add the rule, see here you can able to define the custom TCP port, UDP port, ICMP, custom protocols, all these particular things. Okay. Let's suppose I want to define like custom port for SMTP, right? Now here you can able to define anywhere IPv4, IPv6 or my IP, right? Anywhere means all. You can go with the custom as well, and here you can able to define the CIDR blocks as well. You can also call security groups, means it will support the range, IP range. You can also call the security groups. I will tell you how this reference works. You can also able to define these prefix list. These are the AWS created list for different services. Okay. So when we will use these features, I will show you them as well. Okay. Like anywhere, and we can able to create these security groups like that, and we can able to associate them with our virtual machines. Now I have this VM, right? Now what I will do, I'll go here. Let me launch one more VM. This is VM2 for security group. Now this particular VM I am planning to launch. I will use AWS day 4 key pair, and I will launch this VM on my subnet, which is subnet 2, which is public. Now here you can also, I can do one thing. Either I can use the existing security group. Let me just use this security group. I'll go here 172.16 2.100. Let me launch this VM, and I'll go into my security group. Let me create one more security group. So BPC01 security group 02. Okay, let's suppose in this security group I want to allow the traffic on TCP port, which is 3389 3306. What is the port number for RDP? RDP port number, I forget it. 3389. Yeah, that's correct. I was correct here. 3389 3306, which is MySQL, right? Let's suppose I am also allowing traffic on 443, And let me just also put one more port, which is 23, which is telnet. Okay. BPC, create the BPC. We'll select the BPC. Let me just create the security group. Now I'll go here into this security group, which I have created just now, which is this one, right? I'll go here and on this security group, let me edit my inbound rules. I'll add the couple of rules here. Custom TCP, port range. I can define the port which is 3389 for RDP. Source is anywhere. Then custom TCP port is 23 for anywhere. Then I can also allow the port which is 25 for anywhere, which is the SMTP. And custom TCP for 3306, which is MySQL. So these are the 4 protocols or 4 rules I want to create here. Created, right? These are the 2 security groups. Let me go here. I have these 2 VMs now, right? I have a VM2 as well. Go into this VM2, go into networking. When you will go into this networking, into security, you can able to see which security group. Like this is the security group which is allocated, and these are the inbound rules. You can able to check from here as well. Okay. Now, if you will go here, if I'll go with the security here, and what I can do, I can go with the change security group. See, from here, I can also able to change the security group like from 1 to 2. Add a security group. I can add both of them. I can remove the one, right? So these things also we can able to do. Let me just add 2 security group on this VM. Now, if you will go here into this VM2, into security, now it has a 2 security groups. So guys, one VM can have more than one security group, just remember. Okay. And now you can see all these rules are segregated. Okay. All these rules are segregated together. Okay. And if you will see this particular traffic I have allowed in both the rules, you can able to see this particular rule came from both the security groups. So like that also you can able to do, you can associate the security groups between like multiple VMs, but that security group has a scope at the BPC level only. Means if you have a different BPC, that time you need to create a different security group, just remember. Okay. Now, if you want to take the access of this VM2, you can able to take the access from, open the CLI. Let me take a new connection. EC2 load, select your public IP, SHS console, and copy your keys and login. Accept the key, and you can see I got the access of my EC2 machine. Second VM, right? Sudo -i. Right now, guys, you can see I can able to ping from here, ping to google.com. See, right now I can able to do everything. Even though if I will basically do a curl with 172.16.1.100 on port 8080, you can able to see from VM2 I can able to access my VM1 via HTTPC. I'm getting that particular web page. I can also send the request on port 8080. See, I'm getting the web page, right? Means it's working fine, right? Now, let's do one thing. See, right now we have just done the changes with regards to the inbound rules. Sorry, inbound connection, inbound rules only we have modified, right? But if you will check outbound, outbound is allowing all the traffic, right? So if you want to modify the outbound traffic, you can able to do that as well. You can add the outbound traffic. Let's what you want to. Let's suppose you want to allow the traffic, like you want to allow the ping traffic. So you can go with all ICMP. You can define like from anywhere, or let's suppose you just want to allow the ping between your BPC. So 172.16.0.0/20. Let's suppose you want to allow from this VM2 only what you want to allow only SHS or the HTTP traffic. Let me just select here HTTP. Then just define 172.16.0.0/20. Now go here and towards the internet, let's suppose what you have decided to allow only the HTTPS traffic towards the outside, anywhere. Now this VM2 only able to ping within the subnet, it can able to HTTP within the subnet, but it can only able to connect with the internet over HTTPS. HTTP request will not work. So this is how we can also control the outbound connection as well, guys. Now this time if I'll go, if I do ping 172.16.1.100, ping is working, right? If I'll do the curl, curl is working on this port 80. Let me try on this one. Here also it's working. Ping to google.com. It is working for ping as well. I'm not sure why it is not basically applying these rules, right? Because we have blocked this request. Let me just go into my BPC 01 security group 2. Okay, go here into VM2, go to into your security. These are the inbound rules, right? But we do have a outbound rules, right? See, we have these outbound rules, but there's a one outbound rule who is allowing all the traffic, because on this security group, we have outbound rule who is allowing everything, right? So that is the reason. So when you will combine multiple security group, make sure you have done the configuration correctly. Let's suppose you can just go with 172.16.0.0/24 or 20. If you will modify like that, now if you will go here and if you will do the ping, your ping will stop working. Even though I am not able to access this device as well. See, my terminal is hanged. Why? I'm not able to access because I have denied. And if you will go into this machine this time, where is that EC2 instance? Let me refresh. VM2. Let me refresh this entire tab. This is my VM2. Go into security and in outbound traffic. See, this is my outbound traffic, right? And I have not allowed the SHS, and that is the reason I lose the connectivity. But if I'll go here, if I will just restart the session, I will be able to get that session. Why I'm able to get that session? Because BPC is a stateful device, right? It's a stateful device, and I have an inbound rules, right? Only there is a problem with the outbound traffic. There is a problem with the outbound traffic because in outbound traffic we have modified, right? We have only allowed like that. Means if I'll go here into this VM, if I will try to ping to google.com this time, it is not working. But if I will go and if I'll try to ping to my another machine, which is 172.16.0.1.100, see, ping is working within the VPC. But if I will go and if I'll do the curl to 172.16, 1.100 on port 8080. Port 8080 is not allowed here, right? You can see. But I have this rule which will allow, right? So I will get the connection. See, I'm getting because I have this rule. So whenever you are combining multiple security group, do the things carefully. Recheck all the rules, how they are basically configured, how they are evaluating and all. Now, let's do one thing. I'll go here into select this VM. I'll go into this actions. Before going to this action, let me go here and I'll just edit my outbound rules. And what I will do, I'll just allow all the traffic. There's no any problem to allowing all the traffic. I'll go into this rule as well. Let me allow all the traffic here as well. Here it is already allowed. In this one, it is also already allowed, but for a destination, so I'll select here anywhere. Now I'll go into my VM2. I can basically go with the security. I can change security group and I can remove. Let's say on VM2, I just want this second security group. So like that, we can able to do the things. Okay, so this is how we can able to configure the security groups and we can basically utilize the security group at the VM level. Now, let's go here. Now guys, in this particular diagram, if you have seen, let me increase the size a little bit. Now in this diagram, guys, tell me one thing. I have a security group 1 associated with web server 01 and this web server is running service on port 80, 8080 and 443. I have a security group 2 which is associated with web server 2 and this web server 2 is also having the running the services which is on port 80, 8080 and 443. Now if I want to allow the traffic for these particular 3 internet users and my intention is only allow the traffic for anyone, means anyone from the internet can able to ping these or can able to access these servers on these particular mentioned port numbers. So what type of rule guys I have to modify it in that particular case? If this is only the requirement, I just wanted to allow the traffic towards my web server from these 3 PCs. So I will modify the inbound rule. And what I will just allow only traffic on these 3 ports. Now I have a app servers which is running on TC port 5678 and I have a DB server which is running on TC port 3306. I have a security group 03 and I have a security group 04. Now guys, always see whenever this request coming from the internet, these requests will go towards your web servers only. And if web server needed anything, they will communicate with the app servers. And if this app servers needed anything, they will communicate further with the database servers, right? So if you want to restrict the traffic at app servers or DB server level, you can create a dedicated security groups and you can only allow the traffic. Like what you can do in this security group 3, you can mention if traffic coming from web server 01 and web server 02 and the port number is 5678, just allow it. If we have one more firewall here. We have a one database server who is running the MySQL service on port number 3306. Let's suppose if you want to allow the traffic from these app servers to these DB servers, what you can able to do, you can only allow the traffic on this particular port number. Now let's try to simulate this particular thing. Okay. So I already have a two machines here. This is my first VM. Let me just take the access of this VM again. Not new connection. I just wanted to, it's stuck actually. Duplicate it, close. I have access of my first VM and I have access of my second VM. First VM, where is then second VM? Okay, this is my second VM. Now, guys, I'll do one more thing here. Let me go inside this machine. Sorry, I have to type sudo -i yum update -y, and let me run these services, which is yum install httpd and nginx and vsftpd -y. It will install all these three packages. Right now, I'll go here nano /etc /httpd conf. Inside this conf, we have a httpd.conf file. In this file, just change the port number, which is 80. Instead of 80, we have to go with 8080. Control X, Y, enter. Now systemctl. In systemctl restart httpd restart nginx. Then we have to enable nginx. Then we have to restart and we have to enable httpd. Now see, both of these machine is running these services. If I'll go into first machine, if I'll do the curl on 172.16 2.100 on port 80, see, I will get the web page. Let's wait here. Oh, I'm not getting. Let me go here. Okay, let me look for this security group. This VM as a security, and it is allowing the traffic only from these ports. Okay, I'll go here. Now I'll go into this security group. Inbound rules. Added these rules, and let me just allow the traffic now on. Let's leave it RDP. I will allow 22. Here I will select custom TCP and I will allow port 80. And here I will again custom TCP and I'll just allow the port which is 8080. Why this 2 I'm not able to remove? Okay, it's done. (22) and here let me select here one more port. Which is, let me just allow the ICMP. All ICMP traffic I'm allowing, right? These are the services mostly I'm running there. BSFTP I'm not allowing, so which is good. Now, this time if I'll go here into this machine and this time if I will do the curl and all, it is working, right? I'm getting the nginx, and if I will go with 8080, I'm getting this particular page as well. So now, according to our setup here, I have these web servers, okay? And if you will try to access these web servers, if you will open, let me just tell you the public IP address of these VMs. If you will send the request on this IP address, you can able to get the web page. See, I'm getting nginx and I'm getting it's worked, right? For the second VM, this one, if I will go here and select this IP, I can able to do the same thing here as well. See, I will able to access this And if I will just go with only 80, I can able to get the Nginx. Means my web tier is ready. Now what I want, now what I will do, I'll go here. Let me just deploy this particular app tier. Let me just go and deploy the app tier here. Okay. I'll go with app VM. Okay. Now in this app VM, let me select my key pair and see, I will deploy this app VM on my private subnet. Let's suppose on subnet 04, which is private. And let me just create a security group, which is app SG01. This is for my app tier. And on app tier, what I just want to allow the traffic only on port. So let me allow the SHS. And apart from that SHS, let me allow the traffic on port number, which is, so what's the service I'm running on port number 5678, right? So I'll go here and I'll select 5678. Anywhere, launch this VM. So this is how, guys, you also need to build the things, build the scenarios, and you have to perform the labs. Let me just create one more EC2 instance. And let's suppose this EC2 instance is representing my DB, database servers. Use same Amazon Linux, select the key pair, select your interface, select the BPC01 and just deploy on BPC subnet 05. Create the security group and give this security, which is database DB security group 01 for database. And on database, let me allow, apart from SSH, let me allow the traffic on port number 3306. I think this is the one, right? 3306, which is MySQL from anywhere. You can also like restrict till the BPC level, but I'm just going with the anywhere here. Now, I have created all these servers, right? These are the VMs I'm having. I have a FVM. FVM have this particular IP address, right? So if I'll go into one of my VM here, and on this VM, let me just go into the home location, home EC2-user LL. Let me go into the first VM. I just wanted to look for that particular file, LL sudo -i cd/home/ec2-user LL cd/root LL. Where is that file I have created? cd/home/ec2-user. Now let me just create one key pair file here, guys. I'll just copy this key pair. Nano key pair.pem. Control X, Y, enter. Chmod 600 key pair.pem, then just type SHS -i key pair and just put the IP address of this VM, which is this one, right? I'll go here. The username is EC2-user, right? EC2-user @ Yes, see, I got the access of this particular VM, right? Now, guys, see. Now, what I want to do, in this particular VM, see, I want to run one service on TCP port 5678. And how I can do that? So guys, see, if you will go over the Google, if you will type simple HTTP Python server, if you will search this into the Google, if you will open this particular website, what you can able to do, you can able to run this command and you can able to start the Python server. Means it will start running the web services. Okay, so what I can do, if I will go here. Right now I'm in this particular location pwd at ec2, right? So what I will do, let me create one directory here, mkdir www cd www, and here let me just create one file which is nano index.html, and where I will just put html, then I will put body. In body, let me just put this is app server. Okay, and close your html as well. Control X, Control Y, hit enter. Now you can type Python -m simple HTTP server and define the port number, which is 5678. Hit enter. Oh, Python is not there. And it's a problem, guys. Python 3 hyphen version. Yeah, Python 3 is there. Okay, okay, got it. Control C, quit. Control, I think D I can press. Yeah, I came out. So I can use this command like Python 3 -m, then http.server, and the port number is 5678. See, I am running the app services on my app server right now. If I'll go here into this particular VM, the another one, and from this VM, if I will just do the curl with 172.16 4.229 and the port number is 5678. You can see I am getting this particular web page, which means, see, whatever rule according to this setup, right? I have allowed the traffic from these app servers only on this particular port. How we can do that? If only I just want to allow the traffic only from these particular web 1 and web 2. So guys, see, what used to happen, let's just think about like this. See, we have a security group 01. Let's suppose here also we have a security group 01. Means both web servers is a part of same security group. And in future, let's suppose you have introduced couple of more web servers. Let's suppose you have added around 10 more web servers. Or let's suppose due to big billion days sale, right? What Flipkart wants to add, they have a 2 servers, but due to that sale they have added around 30 servers here. Now if you will add these 30 servers here, now whatever security group we are having into our app servers, what we have to do, now we have to add these 30 IP address into this particular security group. But this is not the correct solution. Let's suppose you have created these particular servers with the help of auto scaling. Then how we can do that? So what we have to do in that case, instead of defining the IP address of these particular server, let's say IP will change. What we can do, we can basically call all these particular instance inside the same security group, which is S01, and this S01 we will call into our S03. That is the security group reference. So if I'll go here, let me just make these changes first. I have this particular VM01, right? Where I'm having one security group, which is SG01 BPC, right? I'll go into my VM02 SG. I'll go into this security. So let me just change the security group here. And what I want to do, I want to add a security group here, which is SG1, and I want to remove this SG2. Add. Now both of my VMs have the same security group, right? This VM2 and VM1, which are my web servers. So what we will do now, I'll go into my FVM, right? In FVM, if you will go into the security, you have this F security group, right? Go to into your F security group. Just refresh here. We have this F security group. Go here in the inbound rule added. And instead of defining this custom IP, what you can define? You can go here, use custom and define the security group. And you can define the security group, which is BPC SG01 BPC. Okay. Or you can delete this. You can add. And now you can define custom TCP. Port number is 5678. And you can define your security group now, which is SG01 BPC. Save it. Means now I have done the inheritance here. Inheritance means now, see on my inbound rule, see, instead of defining the source, I have defined the security group, this one, which is SG01 for BPC01, right? Now let's suppose this particular security group is attached into 20 VMs. Means now these 20 VMs can able to communicate with your F server on port 5678. This is the meaning of this inheritance. And guys, that's how inheritance works in the production environment. Okay, that's how we have to do the same thing. Now let's suppose we have a F security group, right? And we have a database security group. In database security group, what we will do, we will go and edit the inbound rule. And instead of any, what we will do, we will basically go here and we will basically use the custom TCP, and port number is 3306. And what I will do, I will define the security group, which is my F security group. Now this F security group is associated with my F servers only, right? So now the traffic which is coming from this DB, see what I have done, when I've created the rule in this source, I've defined this. And this particular security group is associated with this FVM, means now this from this database server, this FVM can able to communicate. If in future you will expand couple of more FVMs, what you can just put these VMs into the same security group. You don't need to modify anything with here. If you will put on the same security group, because that security group is already referenced here. So it will work in this way. Let me just show you. Let me just go here. This like security or stateful, you cannot reference another security group as a source. You can reference, or we can add like security group as a source into our rules. That's what we have done. Security group do not filter traffic destined to or from the following, means these are the traffic which security group is do not filter, like your traffic for Amazon DNS services, traffic for dynamic host control protocol DSCP, Amazon EC2 instance metadata traffic, Amazon EKS task metadata endpoints, license activation for Windows instance, Amazon NTP traffic or like time sync service, or reserved IP address used by the default BPC router. Okay. There is a one quota, or there is a one limitation for your security group. So yesterday I have said one link, right? You can check out into that link what is the limit for security groups and how many rules we can able to put into one security group, right? You can specify allow rules only with the security group. There is no deny statements. All inbound traffic is blocked by default and all outbound traffic is allowed by default with this default security group. This is the default behavior. When you associate multiple security group with the resource, the rules from each security group are aggregated to form a single set of rules when we will attach multiple security groups, right? We can create a security groups for the protocols based rules, port based rules, ICMP type, code, source, and destination, all of them. Security group referencing. When referencing a security group in a security group rule, IP changes are automatically handled. Means if there is any IP changes happening, it will handled. Reference itself when any instance associated with the SG. So I have one diagram here for the reference purpose. Let me go here. Now if you will see here, guys, see, I have a app servers here and I have a web servers here. Okay. Now this web servers has a one security group like SG01, and this security group is associated with all these three app servers. I have a one more security group for app, and let that security group is SG2, and this security group is attached with all these particular three VMs, right? Now what I want to allow the traffic from these three VMs only on TCP port 1337 towards the app tier. So when I will create this security group 2, what I will do, I will basically define my custom rule, and in the source, I will basically define my SG01 as a source. When I will define this SG01 as a source, means now this SG01 is associated with this VM, this VM, and this VM, right? Means these three VMs can able to communicate. But let's think about it differently. Let's suppose in future, what happens in future, we have introduced here 10 more VMs, and we have just put all these 10 more VMs into the same security group. Then these 10 more VMs can also able to communicate. You don't need to modify the source IP address because in source we have used this reference one. Okay, this prefix list thing I will cover in your end points. Okay, I will, because first you need to understand what is prefix list. Now, so this is how the security group reference thing works. Okay. Now, guys, without wasting time, because we have around 20 minutes, so let me just try to cover your network ACLs as well. Because see, network ACL is not used a lot, so I will not put that much effort on that particular thing. But let me tell you, see, network ACL generally we will use if we want to allow or if we want to deny the communication which is happening between two subnets. See, we have these two BMs into this subnet 01 and we have these two BMs in subnet 02. And if we want to allow or deny the traffic between these two subnets, means if we want to allow the inter subnet communication, like inter subnet communication, communication between two subnets, inter subnets communication we can able to control with the help of network access control list, and these are the ACL which we will configure and this Amazon routers by default. Okay, now let's go here. So network access control list, a network access control list ACS allows or denies specific inbound or outbound traffic at the subnet level. You can use the default network ACLs for your BPC, or you can create a custom network ACL for your BPC with with rules that are similar to the rules for your security group in order to add an additional layer of security to your BPC. So your network ACL works at the subnet level, hence automatically applied to all the instance. Means let's suppose we have created one ACL for subnet 01. And in this subnet 01, we have a 20 VMs. Means this ACL now affect the traffic which is coming towards these 20 VMs or the traffic which is going out from these 20 VMs. Okay. They are the stateless, means we need to explicitly allow the inbound and outbound rule. If they are allowing some traffic on port 80, then whatever response we will get, we need to allow that response as well. Just remember. Contains both allow and deny rules, means in ACL we have a both type of rules, allow and deny. So what I can do, let me just go here into my web UI. I'll go into this EC2. Let me go back to BPC. I'll go into my network ACLs here. And let me just create the ACL. So I will create the ACL for subnet 01 and ACL in BPC01. Like that, we will create the access control list. So if I have a 6 subnet, so I will create a 6 subnet 2 ACL, subnet 3 ACL, subnet 4 ACL, subnet 5 ACL, and let me create one more ACL at subnet 6. I have a 6 subnet, so I will create a 6 ACLs for each subnets. Now I'll go here, I will select my subnet, first subnet ACL. I'll go here and I will just edit the subnet association, and this particular ACL I will just select on my subnet 01. Now I will basically have another ACL subnet 2. So I will basically edit the subnet association and I will basically associate this ACL with subnet 2. I have a subnet 3 ACL and I will associate with this ACL with the subnet 3. Then we have a subnet 4 ACL. So I will associate this ACL with the subnet 4. Now I'll go here, subnet 5, I will associate with the subnet 5 ACL here. Then we have a subnet 6 and I will associate this ACL with subnet 6. This is how we can able to associate the ACLs. Now, if I'll go into my subnet 1 access control list, you can see it has a network ACL ID. It is associated with this subnet. This is the BPC. This is the owner of this ACL. It has an inbound rule. Inbound rule is deny, which means it will deny all the traffic. We have outbound rule, which will deny, means your ACL will deny all the traffic. And right now, if you will go here, see, I'm not able to access any of these VMs. If I will do the duplicate session, I will not able to access. See, nothing is happening. Why? Because now it is belonged at the access control list level. Right now, if I want to basically allow that traffic, what I have to do, I'll go into this inbound rule, go here, I will add a new rule, and this is the rule number, let's suppose 10, and let's suppose I want to allow the traffic on port 22. I can define the source, I can define the action allowed, and I want to allow it. I will add one more rule. I will define the number which is 20. Let's suppose I want to allow the traffic on port 80, then 30. I can basically allow the traffic on port 8080, then 40. I can allow the traffic, let's suppose for ICMP traffic, I will create like 50, and I can allow the traffic, let's suppose on some other port, let's suppose on TCP 21. See, these are my inbound rules, right? Source, and I'm allowing this traffic. But if this time, if you will go and if you will access, still it will not work. It is not working. Why? Because we have allowed the traffic just in one direction. So let me just show you the same thing in this way. I'll go into my EC2 instances. Let me select my instance, which is this VM1. Let me just connect EC2 instance connect. Let me connect with this GUI. See, still I cannot able to connect because my ACL is not allowing that traffic. Okay. So what I will do, if I'll go here, okay, let me edit the rule. Let me here allow one more port, which is port 8080. And I'll go, this is my inbound traffic. I'll go into outbound, and let me go here and let me just allow all the outbound traffic. Add new rule. Then I will just go with all traffic, and I'm allowing all the traffic. This time, if I will basically select this particular VM and I will just copy this IP address, and if I will try to send any type of traffic, see, it's working now. So this is how we can able to basically control the traffic using ACLs, and this time this connection will also work. See, it will work the SHS connection as well, even though I can take the SHS from here as well. See, let me just restart this session and I can able to get the connection. See, I'm able to get it. Okay. So this is how we can utilize these particular access control list for allowing the traffic, for denying the traffic. And if you have, because I know everyone has come from the networking background, you guys have the experience with the CCNA concepts, right? So in CCNA, like we used to configure the ACLs, it's the same thing. Right now, go here. ACL contains allow and deny rules. So we have seen, like it's a, they have a allow or deny both statements. Rules are evaluated in order of the rule number, means the evaluation of these rules will start from top to bottom. Let's suppose we have here, let's suppose I have 100 rules here. So they will start checking first rule, then second, then third. Let's suppose at when it is checking fourth rule, there is a match. And when there is a match, what it will do, it will stop checking the further rules, and it will basically take the actions according to this fourth rule. If it is allowed, then it will allow the traffic. It's denied, it will drop the traffic. Okay, so that's how they will do the matching, top to bottom. Lowest rules number first. Once a match occurs, processing stops. At the bottom, there is a implicit deny rule. And guys, if you have observed, there is a one implicit deny rule at the bottom with every access control layer. Generally, Oscar, people don't use an ACL. Network ACLs is don't use in the production environment. Okay, they don't use. That is the reason I'm not explaining in too much depth now. Rules match the destination IP or range, destination port, protocol, allow or deny based on the match. NACL contain rules grouped into inbound and out, means they have a two type of rules, inbound and outbound rules. Traffic within the subnet cannot be controlled by the ACL. Just remember, see, they cannot able to control the traffic within the subnet, means according to a diagram, if this VM wants to communicate with this VM, that traffic is we cannot able to control with the help of NACL, and this NACL will apply at this router level because they have a this interface and they have this interface, right? So at this interface they have applied this ACLs in inbound direction. Okay, now go here. Default NACL allow all inbound and outbound traffic, means if you will see here, we have one default ACL, right? And if you will check inbound rules, which is allowing everything, it just have a two rules. And first is allow and the lowest one is deny. For outbound also, it is allow or deny. By default, but default ACL, it will allow everything. Just remember. NACL are a great way of blocking a specific IP at the subnet level. A BPC is created with a default NACL, which allow all traffic. Custom ACL can be created for a specific BPC and are initially associated with no subnets. A NACL can be associated with multiple subnet, means one ACL can be a part of multiple subnets. Each subnet can have one ACL, default or either custom, means every subnet at least needs one default ACL. And guys, remember one thing. If you have seen, when we will create a subnet, they all are associated with one of the default access control list. Okay. NACL do not filter the traffic destined to and from the following, means AWS DNS traffic, DHCP traffic, EC2 instance metadata, EC2 task metadata, license activation for Windows, Amazon NTP traffic, reserve IP address used by the default BPC and routers, right? For this traffic also, it will not block that traffic. In network ACL, we have a rule number, we have a type, protocol, port range, source, destination, and allow and deny statement, right? Means in an ACL, what it has a rule number, type, which type of traffic we want to process, then protocol, port number, source, IP address, and all, right? Guys, there's a one more concept of ephemeral port. So the client that initiate the request chooses the ephemeral port range. So if you remember, guys, see, we have a port range starting from 0 till 65535, right? This is the port range where we have a well-known port number starting from 0 to 1023. Apart from 1024 till 65535. These are the port which we can use for multiple purpose, like for NAT and everything. So in similar fashion, like, see, there is a concept of ephemeral port, means I am talking about these particular ranges, means apart from well-known ports, whatever ports are there, we have, they comes under the ephemeral port range. So in devices, Linux devices, they have a ephemeral port number starting from 3 32,768 till 61,000. Request originating from Elastic Load Balancer uses the port number. So if your load balancer is initiating any request, then it will use the port range which is starting from 1024 to 65535. Windows operating system will also use the port range starting from 1025 till 5000. Windows Server will use 49152 till 65535. A NAT gateway uses 1024 till 65535. That is the reason NAT gateway, like one public IP, will support 64,000 sessions. Okay. AWS Lambda uses 1024 to 65535 range. Okay. So these are the ephemeral port range. Now, let's try to understand the network ACLs versus security group, the very basic thing. So generally, as I have mentioned, your network ACLs works at the subnet level and your security groups works at the VM level or instance level, right? So means operates at the instance level. Security group and network ACL operate at the subnet level. Supports allow rules only. They will support like ACL or network ACL supports allow and deny both type of rules. Security group is a stateful and network ACL is a stateless. In security group, we evaluate all rules before deciding whether to allow the traffic or not, right? In ACLs, we will process the rules in the number or order when deciding whether to allow the traffic or not, right? Applies at an instance level. It is applied at the subnet level. Okay. So this is the something like with regards to that. Now, guys, let me just tell you the default BPC thing. So see, whenever whenever you will basically create your account over the AWS, okay, and if you will go into any region, each and every region it has a one default BPC, and that default BPC has a 6 default subnet, and that default BPC CIDR is 172.31.0.0/16. This is the CIDR of that BPC, and this BPC have a 6 subnet, and each subnet have a CID like the like 172.31.0.0/20, then 16.0/20, then we have a 32.0/16, then 48.0/20. Like that, they have a all they have a, these 6 subnets. Okay, so let me just show you this thing. I'll go here. Let me open my BPC console here, and let me just select one of the region called Sydney. If I'll go into this Sydney region, I'll go into this BPC. You can able to see this particular BPC is a default BPC, and how you can able to check it's a default BPC. You can able to see default BPC is yes, which means this is the default BPC. If you select this BPC, you can able to see it has a CIDA range which is 172.31.0.0/16. Apart from that, when you will create this BPC, this default BPC also have a 6 subnets. Only 3 subnets is visible. Let me refresh. I think, okay, let me tell you guys this subnet thing, because I have verified the details for North Virginia region. So in North Virginia region, I have around 6 availability zones, right? So that is the reason if I will create a default BPC in North Virginia region, that time it will comes up with the 6 subnet, means each subnet in every availability zone. Because in this Sydney region, it only have a 3 availability zone. So it will create one subnet on each availability zone. That is the reason we have 3 subnets. Okay. You can able to see these are 3 subnets. We have a route table as well. And that route table is a main route table, even though this route table has all these subnet is associated, and you can see it has a default route as well towards the internet gateway, and we have a internet gateway as well. These are the default thing which is created. Even though this default BPC have a default DSCP option set, it has a default ACL, it has a default security group. So these are the couple of components you will get by default. Now, in which cases these particular things help you? See, let's suppose you are a developer, or let's suppose you are from the DevOps background, and let's suppose you don't have any idea about the networking concepts. Means you don't know what is routing, what is router, all these particular things, right? And right now I'm in Sydney region. Okay, Ketan. So let's suppose you are a developer, and what you want to do, you want to start doing your work. So for these type of peoples who don't have a networking knowledge, what AWS gives the default BPC. They will create a default BPC. They will give the subnets, route tables, internet gateway. Now what you needs to do, even though you will also get the default security group. Now what do you have to do? Now this developer only needs to deploy the VM, and he has to log into this VM and he can start doing his work. For these type of scenarios only, they have created the default BPC, guys. Just remember, means we have a default BPC in each AWS region. A default BPC comes with a public subnet in each availability zone, an internet gateway, and a setting to enable DNS resolution. Therefore, you can immediately start launching your Amazon EC2 instance into a default BPC. You can also use services such as Elastic Load Balancer, Amazon RDS, Amazon EMR in your default BPC. AWS create default BPC in each region. Create default BPC with the CADR, which is 172.31.0.0/16. Create subnet in every availability zone with the CIDR of /20. Creates internet gateway. It has a main route table and which have a route towards the internet. If deleted, you can recreate the default BPC. And if you want to, let's suppose what you wanted to do one thing. Let's suppose this is the default BPC. I can create this default BPC. When I will create, it will give me a warning. See, it is giving me a warning. Are you want to delete this? So then we have to type delete default BPC. You can copy from here. You can type delete it. This is how we can able to delete the default BPC. And if you want to create a default BPC, you can go into action and you can see create default BPC. Create the default BPC and it will create the BPC for you. Okay, so that is all about your BPC. Now guys, see, I have created all these VM. So what you have to do first, the very first thing, you can go here and just terminate them. Set any reason I don't want to do anything. Let me just drop from here. See, these are the VM which is in deleting right now. Network ACL I will just delete later, not now. Always check your BPC dashboard, like what are the resources you are having. So I just have one BPC. I have 6 subnets, 3 route tables, 1 internet gateway, 7 network ACLs, and I can see I have a 5 security group, 1 DSCP option. Apart from that, I don't have anything, which means whatever services I'm having, I don't need to pay anything. Means we don't need to pay for network ACL security group and all, right? So we are good. In EC2, you can go into the EC2 dashboard and check what do you have. So I don't have any running instance. I just have a 2 key pairs, 5 security group, 1 volume, 1 we have I have a 4 instance, but they will delete. Let me just check for the volume. This is the volume. Let me just go here and just delete this volume. Detach the volume here. Okay, because it will delete in some time. I think there is a one machine which is right now this is in shutdown state right now, right? So once it will shut down, it will basically delete the things. Terminate. Okay, so this is how we can able to clear the things like whatever we have created so far. Now, one last thing, guys. So still I have to discuss the net gateway and net instance. So I will basically cover that part in your next class. Once we will complete the net gateway and net instance, I will basically take your BPC. So in next week, let me tell you what I am going to cover. I will discuss this net gateway and net instance, then BPC peering, most important topic, because you will get couple of questions from this BPC peering, and after that I will basically discuss endpoint if time permit, because endpoint also a big topic. I need around 2 classes for that. Okay, so guys, that's it which I wanted to cover with regards to your today's session.